Hi, in this video we will discuss about base width modulation and punch through or reach through concept. Where we can observe this base width modulation in our transistor, we have three regions or three terminals. So what are they? It is our transistor. So transistor is consisting of three terminals. One is known as emitter, base and a collector. So this is our emitter, this is our base and it is our collector. We can find this base width modulation, when collector junction is reverse biased. Here we can find collector junction. So this is emitter. Let us take PNP transistor. It is heavily doped P plus and base is lightly doped N minus and collector is moderately doped, that is P. P plus N minus P. Base is lightly doped, emitter is heavily doped, collector is moderately doped. The junction between emitter and base is known as the emitter junction, that is simply Je. And the junction between collector and base is known as the collector junction, that is Jc. In an active region of the transistor, emitter junction is, this junction is forward biased and this junction is reverse biased, collector junction is reverse biased. When it is reverse biased, connection is like this, that is N type is connected to the positive terminal and P type is connected to the negative terminal, and this voltage is nothing but our VCB. This voltage is nothing but VCB. Okay. VCB is applied like this. In this case, this junction, collector junction is reverse biased. As collector junction is reverse biased, here depletion region is formed like this. Depletion region is formed like this. Before applying this voltage, we can take width of the base as W. Now, when this one is collector junction is reverse biased, there exists a depletion region. In that case, effective base width decreases. So initially we have width of the base is W, and when you apply reverse biasing of the collector junction, the effective base width decreases, that is W is greater than WB. If this voltage increases, means this reverse bias voltage increases, this depletion region increases. Means what? This depletion region is penetrating into P side and N side, but this base is lightly doped compared to the collector. So we know that depletion region can penetrate more on lightly doped side. That means base side can be penetrate more when compared to the collector side. Because of this, effective base width can changes. That means if VCB increases, effective base width decreases. WB effective. We can say this one, WB effective. Effective base width decreases. That means what? By changing this reverse bias voltage, we can change the width of the base or effective width of the base. That means effective width of the base is changing with respect to the voltage. This is known as base width modulation. Means by changing the voltage, reverse bias voltage, we can change the width of the base. This phenomenon is known as base width modulation. Base width modulation. We have three consequences of this base width modulation. we will see one by one. We will see one by one. That is, first one is we have three consequences of base width modulation. First one is increment in the beta. Increment in beta. How these beta will be affected due to that base width modulation. As we know that this one is our transistor. This region is emitter region. This region is base region. This one is collector region. Collector, base, and our emitter. If this one, if this voltage increases, means if VCB increases, effective base width decreases, means as this effective base width decreases, number of recombinations taken place in the base region decreases. Means what? If VCB increases, effective base width decreases. As this one decreases, number of recombinations decreases. Number of recombinations decreases. As number of recombination decreases, IB decreases. As IB decreases, IPC increases. As IPC increases, beta star, that means transport factor, increases. As transport factor increases, alpha increases. As alpha increases, beta increases. Now let us see this one by one. If VCB increases, effective base width decreases. As this one increases, number of recombinations decreases. As number of recombinations decreases, IB decreases. As IB decreases, actually we have the emitter current equation, IE equal to IB plus IC. IC means what? Current in the collector region. So as this one decreases, IC is related to what? IPC plus IC naught. IPC plus IC naught. So this is what transported current. As IPC increases, transport factor increases. As transport factor increases, alpha increases. How we can say alpha increases due to increment in the beta star? Since we have alpha equal to beta star gamma. As this one increases, alpha also increases. As alpha increases, beta increases. So that is the first consequence of base width modulation. Now let us see second consequence. Second consequence is nothing but increment in the IE. Increment in IE. Second one is what? Increment in IE. How this IE increases due to the base width modulation? What we can say about base width modulation? If VCB increases, effective base width decreases. As effective base width decreases, IB decreases. As IB decreases, it leads to what? IC increases. How we can say IC increases due to decrement in the IB? Since we have IE equal to what? IB plus IC. IB plus IC. And we know that IC equal to what? Alpha into IE. IC equal to what? Alpha into IE. So we can say current through the emitter junction increases. Current through the emitter junction increases. That is IE increases. Since IE equal to what? IE is equal to IPE. IE equal to IPE. We can say this one like this also. If VCB increases, means what? Suppose let us say PNP transistor. This one is P and it is N, and this one is P. So here we applied what? Reverse voltage. Means what? N type is connected to the positive terminal and P type is connected to the negative terminal. So here we have VCB. This is what negative voltage. If this VCB increases, means if VCB is large, here it is heavily doped. That means we have large number of holes. So this negative voltage can attract these holes. That means what? It leads to increment in this injected current. That injected current is nothing but IPE. As IPE increases, IE increases. Since IE is approximately equal to IPE. IE is approximately equal to what? IPE. So this is the second consequence. Now let us see third consequence. What is the third consequence? So the concept is known as punch through or reach through. Third one is punch through, or it is also called as reach through. It is also called as the reach through. I said if VCB increases, effective effective base width decreases. That means by changing VCB, we can change the width of the base. This phenomena is known as the base width modulation. If VCB is large, if VCB is large, if VCB is large, for the particular value of VCB, effective base width becomes 0. How we can say this effective base width becomes 0? Means it is our collector region, it is our emitter region, and this one is base region. Because of the depletion region formation, so if you apply a reverse bias voltage, depletion region penetrates to the lightly doped side and this side also. So, but depletion region can penetrate more on lightly doped side as base is lightly doped. As base is lightly doped, this is our base, this is collector. So, if this VCB increases, if VCB increases, so this base width depletion region can penetrate more on this side, and at the particular value of VCB, means for the large value of VCB, this effective base width becomes 0. In that case, this collector and emitter electrically gets short circuited. So if effective base width becomes 0, in that case, this collector region and emitter region gets electrically short circuited. Physically they are not connected, but electrically they get short circuited. If these are short circuited, this applied large VCB, can be applied at the emitter also. So that means this VCB can reach the emitter. So as these are electrically connected together, if this VCB is large, this large VCB can be directly applied at the emitter. That means it can be applied at the emitter. In that case, it can attract more holes in case of the PNP transistor. As it is, so it is P type, it is N type, it is connected to the, so this P type is connected to the negative terminal. This negative terminal can attract more number of electrons into this region. In this case, current increases rapidly. In this case, current increases rapidly. How we can say current increases rapidly? So, it can attract more number of holes from emitter to the collector region. It leads to what? Increment in the collector region, increment in the collector current in the collector region. If this IC increases, power dissipation in the collector region increases. This power is dissipated as heat. If this power is dissipated, if this power is more, in that case, it leads to the damage of the transistor. That means if this power, if this dissipated power may cross the rating of the transistor. If this dissipated power is greater than the rating of the transistor, in that case it leads to the damage of the transistor. So that's why in case of the base width modulation, we have three consequences. First one is what? First one is alpha increases, it leads to increment in the beta. Second one is what? IE increases. How we can say IE increases? IPE increases. If IPE increases, IE also increases. Third one is what? Reach through or punch through. Reach through or punch through. That means what? Reach through or punch through. So electrically conductor region can reach the emitter. This phenomena is known as the reach through. In that case, these charge carriers in the emitter region can give the punches. Means the charge carriers are, let us say it is P and P. In the case, volts are crossing or volts are giving the punches to the collector region for the large VCB. So it is negative and this is negative and this one is positive. So N type is connected to the positive terminal and P type is connected to the negative terminal. In that case, this emitter giving the punches to the collector. So this phenomena is known as the punch through concept or as reach through. Here, collector region electrically reaches the emitter region if this width becomes a zero. Effective base width becomes a zero. So these are the three consequences of the base width modulation. What is meant by base width modulation? If reverse bias voltage increases, width of the depletion region increases. As base is lightly doped, so depletion region more penetrates on a lightly doped side, means base side, at the particular value of the VCB. That means for the larger value of the VCB, base width may become 0. So in that case, we have the reach through concept or punch through concept. In that case, emitter can give the punches, means it can send the more number of charge carriers to the collector. In that case, more power will be dissipated. If this power exceeds the rating of the transistor, then it leads to the damage of the transistor. Okay, thank you.